12.4 Law of Sines. Essential question: can I use a new area formula for triangles that uses trigonometry? Can I use a law of sines? Let's take a look at finding the area of a triangle and see if we can develop this new area formula. Now, the old area formula is the area of a triangle is 1/2 base times height. Let's go ahead and draw the altitude from B to the opposite side. This creates a right triangle. This will be labeled H, the same H that we have over here for the height. Let's now write an equation for the sine of C, because now we have a right triangle. The sine of C is the opposite over the hypotenuse. Now what I'm going to do is I'm going to solve for H. So H will be equal to A sine of C. And now instead of H, I am going to write this new substitution. So this is going to be equal to 1/2 B, and instead of H, I'm going to write A sine of C. And so these two formulas are exactly alike. Now for the most part, I like to remember it this way. It's 1/2 the side times the sine of the included angle. See, A and B are these two sides, and C is the included angle here. All right, so here is the core concept. If you use angle A, you will be using these two sides, B and C, 1/2 BC sine of A. If you end up using angle B, you'll be using these two sides. If you end up using angle C, you'll be using these two sides because this is the included angle. But again, 1/2 side times the sine of the included angle, and then you don't have to worry about letters. Let's go ahead and use this problem. And again, I'm using 1/2 side times the sine of the included angle. The two sides are 19 and 17, and the included angle is 135. Put it in your calculator and you will get that. Okay, let's go ahead and do this problem. A lot of times they give you the information, but they don't label the triangle for you. So I'm going to put angle B here, and it really doesn't matter where you put angle B. And then I'm going to have an A and a C, because this is triangle ABC. Okay, angle B is 60 degrees. Side B, side A is opposite angle A, so that is going to be 19. And side C is opposite angle C, which is 14. So these are the two sides, 14 and 19, and the included angle is 60 degrees. And put this in your calculator and you should get this. Pause the screencast and see if you can do the one right next to it. And here's the answer. Let's go ahead and use this new area formula to help us prove the law of sines. Okay, so we have this area formula where we can use any of the angles. And so all these formulas have to equal each other because they represent the area of this triangle right here. What I'm going to do is I'm going to divide everything through by the same thing, and that way I can maintain the balance of the equation. Now, when I divide everything by that, I'm going to have some reducing going on. And what I'm going to end up with is the sine of angle A over side A. Do reducing. And I'm going to be left with sine of angle B over side B. Reducing. And we're going to have sine of angle C over C. And this is called the law of sines. It's a relationship with sine and the triangle. All right, so the law of sines works regardless of what the triangle looks like. It doesn't have to be a right triangle. It can be any kind of triangle. And not only can you write it this way, but you can write it in its reciprocal form as well. The law of sine is good for solving when you have two angles and a side, either in this orientation or this orientation. It also works for two sides and an angle that's opposite one of the sides, or what we call a non-included angle. Okay, let me go ahead and show you how we use it with angle, angle, side. Okay, we have angle, angle, side, so that's what it represents. Now, when we're solving a triangle, we want to find all the information. So right now, I've written all the sides and all the angles, and I'm going to write down what I know. 107 degrees here, Angle B is 25 degrees, and it looks like side B is 15. I know these three pieces of information. I can find this one because remember they have to add up to 180. So that answer is going to be 48. All right, so what I want to do is I'm going to write the sine of 107, which is this, and it's opposite C, so I'll put a C here. All right, and then I'm going to use 25, and here is angle 25, and the opposite side is 15. We have one more angle, and that is that 48 degree angle, and 48, this is the 48 right here, and the side opposite is A. So now I have set up my law of sines. I'm going to work with these two right now to help me find C. So this is what I'm trying to find, C. Now to find C, I'm going to cross multiply 15 sine of 107 equals C, that's what I'm looking for, times the sine of 25. Now don't go to the calculator yet. In order to get C by itself, you're going to divide by sine of 25. Okay, and then we're going to get C and put it in the calculator. And in the calculator, I'm going to get the answer 33.9. Now I'm going to use these two right here to help me find A. So I'm going to try to find A right here. I'm going to cross multiply again, and that's going to be sine of 25 equals 15 sine of 48. Now don't use a calculator yet. Try to get A by itself by dividing by sine of 25. And we're going to get A is approximately and A will be 26.4. So we're going to put that over here, 26.4, and C is 33.9. And now we have solved the triangle. Let's go to an example where we use an angle side angle piece of information. So we have an angle, we have a side, and we have an angle. So this is what we call angle side angle. Okay, let's write down the information we know. We know that angle A is 71 degrees. We know angle C is 60 degrees. And we know that little b is 150, which is the side B. Now we can find this remaining angle, and this remaining angle is going to be 49 degrees. And so I'm going to put the 49 degrees here, and the side opposite is 150. And then I'm going to write the 71 here. And opposite angle A is little a. The other angle that's remaining is 60, and the opposite side is C, and that's going to help me. I want to work with these two right now, and that I wrote them right here. I went across multiplied, and I isolated my A, and I got A to be approximately this. So that's what I'm going to write right here on A, 187.9. Now I'm going to use these two right here. Okay, and I'm going to cross multiply, and I find C, and when I get C, I get this number, 172.1. Okay, and this is the last case, which is SSA, and SSA is called the ambiguous case because there's two answers. Instead of one answer, there's two answers. Okay, so let's take a look at this. We have angle A is 40 degrees. So I'll put 40 degrees here, and side A is 13, and side B is 16. So the triangle can look like this, all right? And so I'm going to put my numbers in. So A is 40 degrees, and I can put 40 degrees here. You got to do it twice. And B is 16, 16, and A is 13, and 13. Now none of these are right triangles because we have to use the law of sines. So I've already substituted all my values that I know here. And what's missing is what I would like to find is I'd like to find angle B. Okay, I don't want to find this other part here because this would be C and side C, and I don't know what they are. So I have to really use these two because I'm missing something. Now this is the first time I'm asking you to find an angle. Okay, so let's go ahead and cross multiply, and that'll be 16 sine of 40 is equal to 13 sine of angle B. Okay, I'm going to divide both sides by 13. So I have 16 sine of 40 all over 13 is equal to the sine of B. Now, to get B, we're going to have to do that inverse business. So this is going to be inverse, and then we're going to have a big parentheses, 16 sine of 40 all over 13. Okay, and that's what you're going to put in the calculator. So we're going to put sine inverse, and then in the numerator you're going to put 16, and then sine of 40, and then just press the divide side, 13, and then put a parentheses. And we're going to get angle B is approximately 52.3 degrees. So we write 52.3 degrees. But when you're working with side-side angle, angle B might be an obtuse angle, like this over here. So to get the obtuse angle, what we need to do is we need to take the supplement. So I'm going to take 180, and I'm going to subtract 52.3. So angle B could be this big obtuse angle, which is 127.7 degrees. So there are two answers that are possible. We could have this or could this. Now, if this is the case, then I'm going to just subtract 180, subtract 40 minus 52.3. And for this scenario, this angle will be 87.7 degrees. And over here for this scenario, 180 minus 40, take away 127.7, that answer will be 12.3 degrees. Okay, so let's go ahead, and now we can solve for C in this situation. Okay, so this is the situation where the triangle looks like this, where it's 13, 16, and 40. So what I'm going to do right here is I'm going to write, now that I know angle B, my angle C will be here, 87.7 degrees, and then I'm going to write it over C. Okay, so I'm going to work with this right here. So then this is going to be 13 sine of 87.7 equals C times the sine of 40. So C will be equal to 13 sine of 87.7 over sine of 40. So let's go ahead and put that in our calculator. 13 sine of 87.7 divided by sine of 40. Okay, and then so my C ends up being 20.2. So this situation represents this triangle. But side-side angle could also look like this, where B is an obtuse angle. So in that case, this angle is not going to be 87.7. It'll be this right here. So instead of writing sine of 87.7, I'm going to write sine of 12.3 divided by C is equal to sine of 40 over 13. So this is going to be the C for this triangle here. So C will be equal to, and I'll go ahead and just do the work on my calculator, 13 sine of 12.3 divided by sine of 40. And the side that I'm going to get there is going to be 4.3. So this little C is a really small side compared to this side C, which is a big side. And this only happens with side-side angle. You only have to do 2 of them when you're working with that. Okay, let's go ahead and do this one. This is also a side-side angle, side-side angle, side-side angle. So let's go ahead and do it one more time. We're going to write everything down that we know. We know side B, which is 11. We know side A, which is 20. So we'll put them in both lists. And then angle A is 115, and angle A is 115. So I have this 115 over side A, and then angle B over 11. Okay, so I'm ready to go ahead and cross multiply. And so this is going to be 20 sine of B is equal to 11 sine of 115. All right, I'm going to divide both sides by 20. And I'm going to have sine of B is equal to 11 sine of 115 over 20. Now to get B by itself, you are going to have to use sine inverse. So this is going to be 11 sine of 115 over 20. We're going to put that in our calculator. Let's go ahead and do that. Sine inverse. And then we're going to do 11 sine of 115 divided by 20. Okay, and so our angle B is going to be 29.9 degrees, which means my third angle will be 35.1. Now remember, this is side-side angle, so what we're going to do is we're going to find the supplement here. So 180, take away 29.9, and the answer is 150.1. Now, I can already see this situation does not make sense. These two are going to be adding up to more than 180. So for this side-side angle, there aren't 2 solutions. There really is only one solution because the angle B here creates a situation where I'm not going to have a triangle. Okay, I do have one more piece of information that I need to find, and that's C. So now that I have my third angle, which is the 35, so I'm going to write that 35.1, and oops, is that angle C? Let's see. Yeah, that's angle C, 35.1, and then it goes with side C, which is what I'm looking for. So I'm going to actually solve this to create C, and I'll let you go ahead and do that. Okay, last thing is, can you identify which case each one of these are? Can you recognize whether it's angle, side, angle, or side angle? That's all you have to do is identify the case. Pause the screencast and see what you can do. And here are the answers.